Unit 4 is all about the sinusoidal functions. In particular, we need to modeling with given word problems and graphical questions. The question 1 talk about given a temperature for a year round. So the picture associated with the table values. I read through from the table and the read the minimum is negative 24 and maximum is 21. So we know by the formula, the amplitude equal absolute value of A, which is the maximum minus minimum divided by 2. So the amplitude have 22.5. The ELA, also the Q value, equal maximum plus minimum divided by 2, which is negative 1.5. So from here also, because it's from January to December, so it's a year round, we have 12 months. Then the K value equal 2 pi divided by the period, which is 2 pi over 12. We do have pi over 6. And I just sketch the graph, you can see. So this is, it starts from minimum. So I choose cosine, in particular negative cosine. So here's the absolute A, because it starts from minimum. So I choose negative 20.25 as the A value. And here, I assume the start from January, so there's no phase shift. So I put X here. There's no phase shift. So that's the equation multiplied by the first question. So if I want to choose the positive here, it's positive cosine, then there'll be phase shift to the July, which is that'll be 20.5 cosine K, and it'll be X minus 7 minus 1.5. So there can be two cosine function or two sine function, but the first one is the best fit. So I choose the first one is my best fit equation. So now let's move on to question 2. The question 2 is a word problem talk about Faraday wheels. So very similar idea. The given the diameter is 10 meter, we know the radius, which is the amplitude, that'll be also the absolute value of A. The minimum is 1, which is 1 meter, lowest point from ground. So we know the ELA Q value equal the minimum plus the absolute value of A, which equals 6. The maximum will be the minimum plus the diameter, which is 11, and also we can also use the Q value plus absolute value of A, which also give 11. The period, the question gave us the period equal 24 seconds, so the K value equal 2 pi over the period, so give us pi over 12. And quickly sketch this, the height when the time goes by. So here, because we only make one rotation, so I only plot one cycle. It starts from minimum 1 t equals 0 and minimum is 1. So for very similar with question 1, because the first point, which is the most close to the y-axis, is the minimum. So question 2c talk about, so they said to verify 1 t equals 12 seconds, which give accurate accuracy. So 1 t equals 12, if substitute the equation I defined or I found from part B, so why plug into t equals 12? Because pi over 12 times 12, it gives pi. And we do know cosine pi equals negative 1. So the total height will be 11 meters. And let's check. We do know, because the whole cycle takes 24 seconds, then 1 t equals 12 seconds will be exactly half of the cycle, or half period. So the minimum starting from 1, if exactly half period, it'll be on the top. We know the top, which is the lowest point, plus add the diameter. So that'll be total height will be 11. That's exactly the same answer when we substitute the equation. So therefore, they give us t equals 12 is accuracy. T equals 12 gives the accuracy. So left equal right set. Okay, so question 2 is done. Now let's move on to question 3. The question 3 asks us to model the height of the tide. So at the lowest point, the height is 4.5 meters. And at this time, be careful, this time is 24 hours for clock time. The highest tide happens at 17.3 meters and occurs at 8:21. So first we can see very similar idea. We consider the amplitude equal to absolute of A, which is the maximum minus minimum divided by 2. And we can calculate as 6.4. The ELA equal 10.9. So here, if from the minimum to the maximum, those horizontal time difference actually is half period. So again, when we subject, be careful. Here is the time in clock time. So if half period equals 6 hours and 13 minutes, then the whole period multiplied by 2 we do have 12 hours and 26. So here, because 12 hours 26 minutes, I convert to minutes, I convert to hours. And the k equal 2 pi over period. Then we do have this. So convert to decimals is around 0 plus 5. And here, because the minimum point starts not exact from 2, but 208, I also need to convert 208 in hours. So write a fraction. Then therefore, we can see the total, the height function, because start from the most close to the point to the y-axis is the minimum. So I still choose cosine. And the a here is still negative. So here is absolute value of 6.4. Choose negative, that'll be negative 6.4 cosine. The k here are calculated from above. And here we do have the phase shift, which is 2.13 to the right. That will be t minus 2.13. And also need to plug the equation for x as well. The part C, the question asks for, if at 11:30, what's the height will be? Again, we need to convert from clock time to in hours. That'll be 11.5. Plug into the equation I just found from the part B and calculate around to 1 decimal place. So for part D, the question asks for, as long as the depth is equal or greater than or deeper than 12 meters, the boat will be safe. So here I use that, I plug both the function, height function, and y equal 12. So you can see the intercept as 2 points. And from the decimal give, I read the coordinates. Let's see the coordinate for A, let's go B. So here, between these this time interval, the boat is safe. However, when the boat must to leave at this point, so 11.12 and also convert to clock time, that will be 11:07. So here, between this time, the boat is safe, and the boat must to leave at 7 minutes past 11. So this unit is done.